Hello, my name is John Hathcote, and I am an assistant professor and assistant assessment specialist at James Madison University. Today I am going to discuss with you how to use assessment results to improve student learning and/or development. So let us begin. Assessment may be defined in various ways. However, with respect to educational programs, we define assessment as the process of systematically gathering information about student learning and/or development to make evidence-based decisions about program improvement. Notice that the aim of assessment is the generation of actionable knowledge. Closing the assessment loop refers to using assessment results to modify a program, reassessing this modification to investigate whether such changes lead to program improvement. So in other words, we take information about student learning and/or development, modify a program with the intention of making it better, and then we would gather additional information to determine whether indeed these intentions were realized. So within this presentation, I will cover three issues that are critical for using assessment results. And there are various ways that assessment results may be used. But within this presentation, I am simply going to focus on how to use assessment results for the enhancement or improvement of student learning and/or development. So there are two errors that we may make with respect to interpreting assessment results. I am then going to address what we refer to as the black box of assessment practice. This will lead me to the logic of educational assessment, and I will argue that understanding this logic will provide us with a tool for probing the black box. Finally, I am going to conclude by illustrating how we can effectively close the assessment loop. So, there are three possibilities. First, it is possible that the program is effective. The second possibility is that the program is not effective. And there is also a third possibility, which would imply that the program is conditionally effective. What this third possibility would imply is that the program effectiveness may depend upon other variables. So in this case, the program may be effective for some students, but not others. Though I think that this latter possibility is interesting and definitely worthy of investigation, I am going to set this possibility aside. So for the sake of this presentation and for mere simplicity, I am going to assume that the program is generally effective or not effective. And with this assumption in place, there are two errors that we may wish to avoid. First, I may conclude that the program is effective when in fact it is not effective, and we would refer to this as a false positive. Second, I may conclude that the program is ineffective when in fact it is effective. We would refer to this as a false negative. Though there are statistical issues that we should consider here, I will suggest that we may at least in part address this issue by probing what we refer to as the black box. So this may be the typical case. Here I have my students who are entering the program, and we may gather information about them prior to participation. Let's say in a pretest, they go through the program, and then we gather information afterwards. Let's say at a post-test. So the problem is that we often do not have information about what is happening inside the program, and the black box simply refers to this absence of knowledge. We must, prior to program implementation, specify what is happening inside the program that is predicted to lead to specific educational outcomes. In other words, we must probe this box. So what do we need to probe this box? Well, we need theory and data. And for now, I am going to turn to how we may overcome this issue by illustrating the underlying logic of educational assessment. So what I am going to do is to address some arguments. I will then provide you with a simple example and then apply this to assessment results. So let us take a look at our first line of reasoning. We would say, well, if A, then B, A in fact occurs, and then we would conclude, therefore, B. So let us take a look at the example. I could say, if it is raining, A, then it is wet. B, A occurs, so we would say, well, it is raining, and so I could conclude that it is wet. When we apply this to educational programs, we may say something like the following. If my video is effective, then students will perform X. My video is effective, so students will perform X. Now, this line of reasoning is actually good. However, what we really want to know is whether indeed the video is or is not effective. So what would happen if we change the situation? And let's look at the second line of reasoning here. What if I were to say if A, then B, but now we say, well, B occurs, and then I conclude, therefore, A. Let's apply this to our example. If it is raining, then it is wet. I look and I see, well, it is indeed wet, so I must conclude that it is raining. And this is obviously absurd, right? But it can be deceptively appealing when we think about this with a program. So if we were to say, if my video is effective, then students will perform X. Students indeed performed X, so my video must be effective. This is a fallacious form of reasoning and something that we should avoid. So I'm now going to examine something that is referred to as modus tollens. So let us see how this may work. So I may say, well, once again we have our if A, then B, but now I have not B, and then I conclude not A. This is actually a good line of reasoning. So let's see how this would work. If it is raining, then it is wet. It is not wet, so I conclude that it must not be raining. Within the context of a program, we may say, if my video is effective, then students will perform X. Students did not perform X, so I conclude that my video is not effective. Like I said, this is referred to as modus tollens and is actually a good line of reasoning. So let's think about another situation that is considered, or at least what I would consider to be a key issue. So we may ask, well, under what conditions would my hypothetical, my if A, then B, turn out to be false or incorrect? Well, there is only one condition where this would occur. This would occur when A is true and B is false. And this is so precisely because this is the very condition that is specified as something that cannot occur according to my hypothetical. So let's take a closer look at this to see how it may work. So here, once again, my hypothetical says if A, then B. And I have mentioned that this will be false when A actually occurs, A is true, but B does not occur. So if I were to take my other example and say, well, if it is raining, then it is wet, and simply ask, well, what would make that statement false? And we would say, well, this is false if indeed it is raining, but it isn't wet. With respect to a program, how might this work? Well, if my video is effective, then students will perform X. And what conditions would make this statement false? This is false if students watch the video, but they can't perform X. So we may connect this again to information about implementation fidelity. And if you want to know more information about that, you are more than welcome to see our other presentation. So in this case, we have a single objective. After completing the program, students will be able to list 3 effective test-taking strategies. This is mapped to a program component that we call Workshop 1. Within this workshop, students will watch a video about test-taking strategies. So let's look at our reasoning. If students watch a video, then they will be able to list 3 strategies. Well, under what conditions would this be false? Well, like we said, when A is true, but B is false. So we know from the implementation fidelity assessment that A is true. And we can see that here, because we know that this actually occurred within the program. So if they cannot list the 3 strategies, then we are building a decent line of evidence to suggest that the video is not effective. So let's consider some possibilities for how we may handle this situation. So once again, we have a specific feature here that is mapped to a program, or at least to a program outcome, and we're going to ask, well, what would we do if this outcome was observed? Well, in this case, we would say, well, B was observed, and indeed, this would be great news. So in this situation, we would need to be careful about fallacious reasoning, but nevertheless, we may choose to use assessment results by continuing to monitor student performance in subsequent years. Now, what if we didn't observe B? Well, this information is actually quite informative, since it applies to the situation from my previous slide. But what would we do in this situation? Well, we may choose to replace the video with something else. So perhaps instead of watching a video, they would do, say, a group discussion. An alternative strategy would be to supplement the video with something else. So in this case, they would watch the video and then they would follow this up with a group discussion. So in order to close the assessment loop, we would simply make these changes, reassess this modification to see whether these changes led to improvement, and we would repeat this process until our outcome was achieved according to some standard. So let us see where we have been. First, I've indicated that there are 2 errors that we would like to avoid. It is conceivable that we will conclude that an effective program is actually ineffective, and this may lead people to argue that we should terminate a good program. This is obviously something that we would like to avoid. Secondly, we may believe that a program is effective when in fact it isn't. So other possibilities are at work, or at least they could be at work, such as the idea that a program could be conditionally effective. So some caveats are necessary here. There are also some statistical considerations that we need to look at when we make these decisions, but I have suggested that these issues extends beyond statistical concerns. Ultimately, this problem is made worse by what we would think of as a black box. So to put this simply, you cannot effectively use assessment data if you fail to articulate how educational programs are intended to function. This can be derived at least from 2 pieces of information, and in fact it should be. First, you should really get this information from theory. Secondly, you need to probe this box with data and get information about what is actually happening inside a program. So with this information, the 2 errors that I discussed are at least going to be not as problematic. Now, I don't believe that we're ever going to completely eliminate these issues, But I do think that if you follow these ideas, you should at least be able to construct a decent argument that is informed by empirical observations. So I have provided you also with some basic arguments that could be used in a context of educational assessment. And I then illustrated how we could combine these ideas with implementation fidelity so that we may effectively close the assessment loop. So before closing, I would like to thank you for your time. And if you do have any questions, then please feel free to contact Student Affairs Assessment and Support Services at James Madison University. Thank you.